My name is Sankaran Mahadevan. I am the John R. Murray Senior Professor of Engineering here at Vanderbilt. Obviously, if you are concerned about reliability and risk analysis, it's not just a one-time thing at the beginning of the life of the system, but it's something that you are concerned about throughout the life of the system. So, therefore, one of the subgroups also is heavily involved in structural health monitoring problems and methods to address those. So we are focused on both civil systems and aerospace systems, and we have looked at methods particularly focused on two types of techniques. One is based on bond graph techniques, where we are able to quickly isolate or localize the faults or defects in the system. And then the Bayes networks technique. So we heavily employ Bayesian techniques for quantitative estimation work. And so there are two types of techniques that we employ. One is the parametric techniques, where we are going to try and estimate the parameters of the system that are physically understandable. And then there is also the non-parametric methods for detecting faults in the system. And in both of these, the main focus is on looking at the uncertainty in diagnosis and prognosis, because obviously you are looking at a variety of techniques, and they all come with a lot of approximations, whether it is in measurement or data processing or in the models and the simulation that you employ. And so there are many errors and approximations. So how sure are you about your diagnosis or prognosis about the system's remaining useful life and its operational capability? So we look at all the different sources that contribute to the error and uncertainty in these processes and come up with an overall estimate of confidence in our diagnosis and prognosis. And we have applied these techniques to both buildings and bridges in the civil infrastructure systems, and also to aircraft actuators. And one of the issues also here is uncertainty management, where as the system is progressing through its life, obviously you are getting newer and newer information, whether it's by monitoring the operations and the loads on the system, or by doing periodic inspections and maintenance and so on. So how to integrate all this information that you are accumulating through the life of the system. And so this uncertainty management and uncertainty reduction, and which of course leads to then your decisions about what to do in terms of logistics, maintenance, in terms of how to operate the system. So all these issues also we consider under this subtopic. And we have research going on right now funded by DOE and the Department of Defense, especially the Air Force, and also NASA, looking at these topics. So if you look at the particular projects that the students are focusing on for their thesis or dissertation topics, we have Greg Bartram, who is developing a Bayes network technique for integrating information. And you know, this information is quite heterogeneous, in the sense it comes from a lot of different sources. There is some that comes from design and from mathematical models. There is some data in the literature. There is some experimental data. There is operational data that's being gathered, monitoring, inspection, so, and some expert opinions. So all this data is very heterogeneous in many different formats. So he is developing a Bayes network technique for integrating heterogeneous information in order to help diagnosis and prognosis. Sankaran, who just finished his PhD, he particularly focused on the uncertainty quantification in diagnosis and prognosis, when we do diagnosis, we are doing detection, and then we do localization of the faults, and then actual estimation. And there is uncertainty in each one of these steps, and how to quantify those things so that we can put a level of confidence in our diagnosis and prognosis. So that was his work. And connected to that is another student, Yuling's work, who is looking at particularly the application of these techniques to fracture problems and crack growth modeling as well as monitoring. And he is also helped by Adam Wolf, who is looking at particular aspects of these techniques.